Okay.
Good evening once again. Good, good evening. So, mm, brother, what again? Thank you for joining us. We 1 hour ago we started the class with electric feed on our TikTok account, but we are moving now. We'll move back to our account on YouTube. So as we proceed on the topic electric feed, just want to give you a clue of this within 30 to 1 hour. Then subsequently, we are going to release videos personally on our YouTube page, TikTok page, Facebook page, as well as this electricity topic. So we just want you to remain focused as we start. So we promise you along the week like this, we will have a short video like this so that to encourage you to be able to watch our live video. So I thank you. So in the circles as shown above, when the key is closed, the readings on the ammeter will be dashed. The readings on the ammeter will be dashed. We want to look at the readings of this ammeter. This is a normal electrical circuit. You have a resistor 1 ohm, another resistor 1 ohm, another resistor 1 ohm. We have our key battery, like our battery here. although it's just a single symbol here, but we know it's two cells because we can't have a cell that is more than a cell that is more than 1.5 volts. Since it's two cells and 3.0 volts, then we have a key and we have our ammeter. We use the ammeter to measure current. So we are told to calculate the readings on this ammeter here. So our major concern will be we'll look at the resistor first. This is our battery. That's our battery. This we can tell this one as R1. Okay, or okay, maybe we make this R. Wait, let's start. This negative, this plus. That means the current will flow from the key. The key will be plugged. Then the current will flow here from the battery. Our source current. The source current will move here. It will ammeter will confirm that, but when it gets here, they are all in sync, so the same current will flow across. But when it gets to this node, the current will be split into two. Which let's start this one I1. Let's start this I2. The current is split there at this particular node. Refer to this as node or junction. The junction is just a point in the circuit whereby current can be shared. So you see the source current here. So we know from here that the source current Is is equal to I1 plus I2. That is, the source current has been split into two, which proves that this resistor R1 is in parallel with this resistor R2, and both of them now join back together here as Is. So they will now flow again to reach this one here, to reach I3 here. So which also confirm Kirchhoff's law that the source of current entering a circuit is equal to the source of current leaving the circuit. That was the Kirchhoff current law. That was the first law of Kirchhoff's law. So from there we've confirmed that. So we do the flow of the current so that we'll be able, through the flow of the current, we'll be able to ascertain which resistor is in series of power. You can't ascertain with the wire connection being drawn through the lines on the diagram. But we can only know through the flow of the current. So with the flow of the current here now, it's the same Is. The same Is will still flow back here. Same source current will flow back here, which confirms what we are saying. Still the same Is here. But when it got here, you see that it's being shared. Hope what we are saying is clear. If my voice is clear, my explanation is clear, please kindly say clear. Kindly respond by saying clear. As many that are joining, kindly respond by saying clear. Alright, if my conversation is clear, let me know. So we discover that R1 and R2 are in parallel. So let's resolve that first. So we say 1 over, we make the combination of both of them since they're in parallel. So R1 and R2 are in parallel. So 1 over RT1 is equal to 1 over R1 plus 1 over R2. So 1 over RT1 will now be my LCM. This will be 1 over 1 plus 1 over 1. So my 1 over RT1 will now be LCM is 1. 1 divided by 1, 1 times 1, 1. 1 divided by 1, 1 times 1, 1. That will be 2 over 1. So I can now integrate here. Excuse me. So that will be RT over 1 will still be 1 over 2 ohms. So that's the result. So when I solve these two in parallel, it will be in series with this one. So here will not be the R1 and RT1 are in series. And that will be 1.5 ohm, half plus half. So my RT2 is equal to 1.5 ohm. So since the cell does not have internal resistance, the internal resistance is negligible. So we can say from here, we know that our current is equal to the battery all over external resistance. Since internal resistance, if there's internal resistance, we would have had plus more half. But since there's no internal resistance, so here will not be P over 1.5. So my answer will be 2.0 ampere. So that's my source current there. So my highest is equal to 2.0 ampere. So that's all. Thank you. If it's clear, let us know. If it is clear, let us know. Just let us know. Look at it very well and confirm. That's why 2017 is an objective question, but you know it should be more than 1 mark. I think it should be up to 3. Confirm. Who was around? Okay. 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 Is it? Okay. But allow it. Please look like. Okay. Let me do one more. Ah, that I remember. Bond. Okay. I need it. Okay. 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 Is there any forces now? Okay. Okay. Right. No problem. Just one more. Which is if we go at our goal, download there. Eh? So we're told that a cell of EMF 1.5 volts is connected in series with a resistance of 3.0. So we are going to draw, it's given to us in Word. I'm going to draw the diagram. Let's start with the cell. This is the cell. So, 1.5 volts is connected in series with a resistor of 3.0 ohm. 3.0 ohm. And a voltmeter is connected across the cell. This is the series. Voltmeter is connected across the cell. So if it's across the cell, we can place it here. Voltmeter connected across the cell. Calculate the internal resistance of that particular cell. So this is our external resistor. E is equal to 1.5 volts. 1.5 volts, but it has an internal resistance. So the voltmeter is 0.9 volts. That's the reading of the voltmeter. And take note of something. Your external resistor is equal to 3.0 ohm. Then the reading on the voltmeter is what we refer to as terminal voltage. Terminal voltage, okay, is 0.9 volt. It's also known as the voltage of the current that come from the battery and the external resistor. So, and is denoted with VT. Can be denoted as VT, which is equal to IR, that is current times external resistor. So these are external resistors. So from that, then our battery E is equal to 1.5 volts. So, and in terms of the relationship, we have what we call V small r. We refer to it as lost voltage. Okay, lost voltage, which is the lost voltage is current, same source current, multiplied by internal resistance of the battery. So we know that from here, from our knowledge, we know that the ET or E of the battery will be VT, the terminal voltage or potential difference across the external resistor, plus V. Okay, let me tell you that VL, which is the lost voltage. So from here now, I can now get my lost voltage. I can say from here, my ET is equal to, my ET is the source voltage at 1.5, my left 0.9 plus my VL. So here will now be 1.5 minus 0.9 is equal to my VL, and my VL will now be 0.6 volts. So I've gotten that. So I can now easily say from here, if you recall from Ohm's law, that my VT is equal to IR. So I can get my I as VT over R, and that will be 0.9 over 3, and that will be 0.3 ampere. So that will be my self voltage. So from there, I can easily get my internal resistor there. So my VL is equal to my I times small r. So my L will just be VL over I. So that will be have the same thing as 0.6 over 3. So my internal resistor is just 0.2. And that's my answer. So my answer is given as 2.0 ohm. 0.3 over 0.3. So this is 0.3. 0.3, and that's 2.0 ohm. So this is 0.3. So that illustration is clear. Very simple. Right? 2009. Very simple. Very simple. It is clear. It is clear. So very simple as illustrated. Just as we illustrated, let me explain that. The cell is 1.5 volts. The internal resistance was not given. This is the external resistor. This is the terminal voltage. That is the voltage from the flow of current and the external resistor. So our external resistor is 3.0. The terminal voltage is 0.9 volts. So my E is equal to 1.5 volts. VL is my lost voltage. This is current times internal resistor. So my heat will now be Vt plus VL. Here is 1.5. Go to 0.9 plus VL. Here will not be 1.5 minus 0.9. That will be 0.6 volts. So here my Vt is IR. I is equal to Vt over R. That is 0.9 over 3. That is 0.3 ampere. So I've gotten my source voltage, source current from there. So my VL is current times internal resistor. So my R is equal to VL over I. That is 0.6 over 0.3. And that's 2.0. So that's all. Thank you. So we thank you for today. You subsequently you will see our flyers. Those who have been following us, we appreciate you. We promise to release more live videos. Thank you. Please comment. Let us know where there are mistakes and let us know where to improve on. But we can assure you all the questions are proof of WAEC, JAM, and NECO standard questions. Thank you. God bless you all.